Okay, so next we are going to proceed with the tabular method first. Okay, so your tabular method now you will have, so this is sign, differentiate and integrate. So you are going to differentiate 3x over pi and you are going to integrate cos and x. Okay, so this is plus sign. So for the second one it will be, so differentiate this one will give you 3 over pi and differentiate a constant will give you 0. Okay, so settle with this one. So for integration part, you have SC, C negative S. So this is differentiate and this is integrate. Okay, so integrate cos will give you sine. So sine nx over, and you have to differentiate the argument inside here, then we'll have n. Okay, the next one is integrate sine will give you negative cos nx over n squared. So how I get this n squared here, because as for this one, 1 over n is a constant, so I factorize it. Okay, so integrate sine will give you negative cos nx over, so differentiate the argument here will give you n. So that's why you end up with negative cos nx over n squared. Okay, so these are the result for the tabular method. Okay, so now for the first part here, this is direct integration. So therefore your an is equals to 1 over pi. So for the first function here, so 3 is a constant, so differentiate integrate cos will give you sine. So you will have 3 sine nx over n. Okay, so 3 sine nx over n. So your upper limit is 0, your lower limit is negative pi. Okay, plus, so for the second function here, so this is your result based on your tabular method. So therefore you will have 3x over pi n sine nx. Okay, 3x over pi n sine nx. So minus minus, then you will have plus 3 over pi n squared cos nx. And for this one, your upper limit is pi and your lower limit is 0. Okay, so now you are applying upper limit minus lower limit. So for the first one, your an is equals to, so 1 over pi. So for the first function here, when you substitute x is equals to 0, so sine 0 is equals to 0. Minus, for the second function, you will have 3 sine negative n pi over n. So settle with the first part. Okay, 3 sine negative n pi over n. So for the second function here, so plus, so what is the the upper limit? So pi. So you need to substitute. So the first one will be 3 pi over pi n sine n pi plus 3 over pi n squared cos n pi. So this is the upper limit minus by the lower limit. Okay, so your lower limit is 0. So when your x is equals to 0 here, so 0 multiplied by any function will give you 0. Plus 3 over pi n squared. So cos 0 is equals to 1. Okay, so therefore close bracket. Okay, so to simplify this one, you need to use this. Okay, so sine 0 is equals to 0. Okay, cos 0 is equals to 1. This one you already know. Okay, so when you have sine n pi or sine of negative n pi, this one is also equals to 0. Here I prove for you. When your n is equals to 1, so sine pi will give you 0. Sine of negative pi is also 0. You can just press your calculator by setting your calculator in radian. Okay, for your when your n is equals to 2, sine 2 pi is equals to 0. Sine negative 2 pi is also equals to 0. So therefore, whenever you have sine n pi or sine negative n pi, so you can just simplify it to be 0. You don't have to show this one. I just show to you to prove that this is equals to 0. Okay. Okay, for this part here, cos n pi or cos of negative n pi, this one is not equals to 0. Okay, this one is equals to negative 1 to the power of n, where your n is an integer. Okay, so let's take an example if your n is equals to 1. Okay, cos pi or cos negative pi is equals to negative 1. Remember, in my first video of this chapter, you have cos of negative x is equals to cos x, isn't it? So that's why when you have cos of negative n pi, this one is equals to cos n pi. Okay, so when you are considering your n is equals to 2, then you will have negative 1 squared. So the answer is 1. And this one is repeating, negative 1 1, negative 1 1, and so on. Okay, so when your n is an odd number, then you will have negative 1. When your n is an even number, then you will have 1. So that's why if you have cos n pi or cos of negative n pi, you need to simplify it to be negative 1 to the power of n. Okay, because for the Fourier series, we are considering from n is equals to 1 until infinity. Okay, so this one I just showed to you. Okay, so when you have this one or this one, you need to replace by negative 1 to the power of n. Okay, this one is a rule of indices. Okay, negative 1 multiplied by negative 1 to the power of n. So you have the same base, so you need to plus for the power. So that's why you have negative 1 and plus 1. So do you really need to simplify by using this one? Yes, you have to. If not, you don't get the final answer. Okay, so by referring to this one and what you have here, okay, so now you have sine negative and pi. So you know that sine negative and pi is equals to 0. So therefore this one is also equals to 0. Okay, so here sine n pi. So again sine n pi is equals to 0. So this one here 0. Okay, and you left with cos n pi. So this one you need to replace by negative 1 to the power of n. Okay, so therefore if you simplify this one, you will have 1 over pi. So this one 3 over pi n squared, negative 1 over n, sorry, negative 1 power n, minus 3 over pi n squared. So if you expand this one and this one is the same thing, so you can factorize it. So therefore you will end up with 3 over n pi squared, negative 1 to the power of n minus 1. So therefore this is your an. Okay, this is not yet the final answer. Okay, this is your an. So how I get this n pi the whole thing squared? Because when you substitute here 1 over pi multiplied by 3 over pi, then you will have pi squared. And also for this one you have pi squared. So pi squared and squared. So that's why I rewrite it as n pi the whole thing squared. Okay, and this one I just factorized. Okay, so settle with your en. So the last one is you need to calculate your bn. Okay, so how are you going to calculate your bn? So the same thing for the front part here, but your fx now need to multiply by sine n pi x over l. So therefore you will have your bn is equals to your bn is equals to 1 over pi, since your l is equals to pi, negative pi to pi fx sine nx dx. Okay, because your l is equals to pi, so you can cancel out. Okay, so please be careful when you want to cancel out this one. This one you can cancel out because this is the argument in the bracket. Okay, but if you have something in this form, you cannot cancel out. Okay, let's say you have sine n pi x the whole thing over pi. Okay, this one you cannot simply cancel this one and this one. That is wrong. Okay, you need to leave as this one. You need to leave this answer as this one. Okay, so your answer will be 1 over pi sine n pi x. Okay, you can just simplify if it is in the same bracket here. So if let's say you have sine n pi x over pi, this one in the bracket. Okay, so that's why this pi can cancel out. Okay, so please be careful. So now we're going to proceed with your bn. So for your bn here, so again your function, you're using the same function, which is this one. Okay, this is your lower limit, upper limit, the first function, the lower limit, upper limit, your second function. Now this function need to multiply by sine and x. Okay, so the moral of the story here, if you start with the wrong things, then you will end up all wrong. Okay, so that's why you need to be careful. Okay, so if you apply this one here, so just multiply by sine x, and this function multiply by sine x. So therefore you will have your bn is equals to 1 over pi. So your first function, negative pi to 0, 3 sine nx dx, plus 0 to pi 3x over pi sine nx dx. Okay, so again here, as you can see here, so this is direct integration, but as for this one, this is tabular method. So you need to do tabular method. Okay, so for the tabular method part here, so you are going to differentiate 3x over pi, and you are going to integrate sine nx. Okay, so this one integrate. Okay, so for the first one here, differentiate 3x over pi will give you 3 over pi, and differentiate 3 over pi will give you 0. So this is plus minus plus. Okay, now sine x. So integrate sine will give you negative cos nx over n. Okay, and integrate cos will give you sine. So negative, you still have it. So negative sine nx over, so again this one you differentiate, you have n, so n multiplied by n, then you will have n squared. Okay, so therefore this is the answer for the tabular method part. So now your Bn will be, so Bn is equals to 1 over pi. So what is the first function? So integrate sine will give you negative cos. So you will have negative 3 cos nx over n. So please be careful. This n you cannot simplify by this n. Okay, because this is over the whole thing, not in the bracket. Okay, so that's why you cannot cancel out the n. Okay, so what is the upper limit here is 0, the lower limit is negative pi. So plus, so for the second function here, you're going to take the result from your tabular method. So you will have negative 3x over pi n cos nx. Okay, so minus minus, then you will have plus 3 over pi n squared sine nx. For this one, your limit will be, upper limit is pi and lower limit is 0. Okay, so next is to apply upper limit minus lower limit. Okay, so therefore this one is equals to 1 over pi. So cos 0 is equals to 1. Okay, remember it should be upper limit minus lower limit. So cos 0 is equals to 1. So you are left with negative 3 over n minus, okay, upper limit minus lower limit. So when you substitute your n is equals to negative pi, then you will have negative 3 cos negative n pi over n. So this is your first function. Okay, upper limit minus lower limit. For the second function here, so your upper limit will be pi. So you will have negative 3 pi over pi n cos n pi plus 3 over pi n squared sine n pi. So this is upper limit for the second function minus, so lower limit for the second function is 0. So when you substitute here 0 here, so 0 multiplied by any function will give you 0 plus, so again here 0 sine 0 is equals to 0. So nothing left for the second function. Okay, so now you need to simplify by using this one again. Okay, so you will have, so for the first function here, cos of negative n pi, so this one is equals to negative 1 to the power of n. Okay, cos of negative n pi, so this one is equals to negative 1 to the power of n. This one can cancel out. Okay, sine n pi is equals to 0. So this one is equals to 0. Okay, so therefore your answer will be, so this one is equals to 1 over pi multiplied by negative 3 over n. So minus minus will be plus 3 negative 1 n over n minus 3 over n negative 1 n. Okay, and as you can see here, this is the same function. So plus 3 minus 3 will give you 0. So therefore this one cancel. Okay, because plus 3n minus 3n is equals to 0. So you left with your Bn is equals to negative 3 over n pi, or pi n, is up to you. Okay. So, okay. Sometimes you will also end up with the answer is equals to 0. Okay. So don't panic if you calculate for your neither function. If you calculate for your a naught or your an or your bn, one of this function, one of this Fourier series coefficient, and you get 0, that's okay. Okay, because some cases there is the answer where your bn is equals to 0 or your an is equals to 0. Okay, so now you already have your a naught, you already have your an and your bn. So now you are going to write your Fourier series expansion here. Okay, so for your Fourier series expansion, your fx is equals to a naught over 2 plus summation of n is equals to 1 to infinity an cos, since your L is equals to pi, so cos nx plus bn sin nx. Okay, so now you are going to plug in your value for a naught, for your an and bn. Okay, so if you calculate and you get your an is equals to 0, so therefore you don't have this function, because 0 multiplied by any function will give you 0. Okay, but for this example you have the value for a naught, an and bn. So your a naught is equals to 9 over 2. So 9 over 2 divided by 2 will give you 9 over 4. So therefore your fx is equals to 9 over 4 plus summation of n is equals to 1 to infinity. So what is your an? So your an is equals to this function. Okay, so your an is equals to 3 over n pi squared negative 1 power n minus 1. So this is your an cos nx. Okay, plus, so what is your bn? So your bn is equals to negative 3 over n pi. So plus, so plus minus will give you minus 3 over n pi sin nx. So therefore this is your Fourier series. Okay, what is meant by Fourier series expansion? If you considering n is equals to 1 until n is equals to infinity, okay, and you plot, and you will have a graph, either cos function or sine function. So that is the aim of the Fourier series, to represent the periodic function in terms of cosine or sine function. But for your syllabus, we just have to know up until here. So just write your Fourier series. Okay, so this one. So this is just the first example. Okay, I am so sorry because I take a long time to explain one example. So I shall see you in my next video, and I will explain another example for neither function before we proceed with other types of function. Okay, so I hope you are able to understand this one. Okay, so I shall see you in my next video for the second example of neither function. Thank you guys.